Recently, when I was doing lead code problems, I realized that what if we learn data structures and algorithms by implementing those knowledge in solving real world use cases instead of solving random DSA problems? So that's when I started working on a small project, which is like a social media platform. So let's take Instagram for example. So Instagram has features like adding friends, adding posts, removing friends, showing mutual friends, etc. So I have like what I did was a small prototype of that. I implemented those features using the data structures and algorithms that I learned. In this video, what I'll be doing is I'll be walking you through what I did, how you can do it, and I'll also be explaining all the codes that I've written. So now let's dive straight into the code. So now before like explaining all of these functions, let me just run the whole code so that you can have a better understanding of what it's like. Let me run it. So as you can see, I've run the code and these are the functions that I've implemented. Add user, add friends, add post, show friends, show mutual, remove friend and exit. So first let's try adding a user. It would be me, Chal. Next, let me add another user, my brother, let it be Viber. Okay, then let's add another user. Mm, ah, let's add Spider-Man. Spider-Man is another user. Now we have three users added to our database. Now let's try adding friends. I want to become friends with Spider-Man, so let's select option 2, which is for adding friends. Charles, Spider-Man. Okay. Now me and Spider-Man both are friends. Let's check if we both actually are friends or not. For that we need option 5, show friends. Vishal, friends of Vishal. You can see after I wrote this, Spider-Man has been printed, so it's working perfectly. So friends is working. Now let's add post. I want to add a post, so it's option 3 over here. Let me click option 3. Vishal, it's me who I want to add post. Let's name it post 1 for now. Okay, I've added a post successfully. Now let's see if it works or not. To see my posts, it's 4. It's my post of Vishal. You can see Vishal has posted post 1. Let's try adding another post. Vishal post is post 2. Now let's see my posts again for Vishal. You can see that Vishal has posted post 1 and post 2, so it's working fine. Now let's try mutuals. For mutuals to work, we need to have like interconnected friends. So as of now, me and Spider-Man are friends. Now let's make Viber and Spider-Man friends. For that, what are we supposed to do? Add friend is 2. So let's add Viber and Spider-Man as friends. Okay, now they both are friends. Now let's make me and Viber friends. For that, Vishal, Viber. Now we both are friends. So if you think about it, me and Spider-Man are friends, Spider-Man and Viber are friends, and me and Viber are friends. Let's try. Show mutuals. Spider-Man and Viber. You can see the mutual friend of both Spider-Man and me are Vishal. Like if it's hard to like understand it now, like I'll explain all of these function in a moment. So stay tuned. So almost all the functions have been implemented. Now let's say that there's a fight between me and Spider-Man. So I don't want to be friends with him anymore. So let's remove our connection. Vishal. Okay, now me and Spider-Man have been our connection has been removed completely. Now let's check my friends. Vishal. Now only Bibo is my friend. Spider-Man is not my friend anymore. Now all the functions have been implemented. So let's exit the function. That's all. This is all that I've done till now, and I'll be explaining all of these functions in a moment. Okay, We just saw how the code ran. Now we look into how it's implemented in the C language. So first, obviously, we have to include all the header files. The next is we have defined struct user and struct post. Struct, what is struct? Struct is nothing but a user defined data type. So let's say that you don't want to use the predefined data types such as int, char. So in that case, if you want to define your own data type, we use struct. Our user defined data type is called user struct user, and inside struct user we can see that there are multiple other items which has its own data type. So we see that it has a variable called name which is of data type character, and we have a variable called friends which is a pointer. This pointer actually points to one other item which is of type struct user, and that's why we have given struct user as a data type for it. Similarly, we have posts and next pointer. If you're like seen, I've used struct post for this because this pointer points to another item which is of data type struct post. This is another user defined data type. It has character of post and a pointer which is of struct post data type. Now let's get right into the functions. As we can see, the first function that I've implemented is add user. So like I'm not just gonna explain the code line by line. Like it would be great if I explain all of these using a diagram. So this is it. I'm going to implement this thing. So let's keep this aside. So before starting it, I would like to tell that I've chosen a linked list for storing users in the database because I don't want to limit the number of users, because like when you're declaring a array, you need to specify the number of users in it. And in case you can say that like I can put maximum number of users, but that takes the whole space, right? But in case of linked list, you can see that it takes the space of only the items that are present in the linked list. And also there's another case. In case let's say this is already present, I want to remove Vibo user from the link from the database. So in that case, if I'm using a linked list, I can directly remove it and connect this pointer to hacker. So let's say I'm using an array. In that case, I have to remove Vibo. This place would be empty. This index would be empty. And consider there are thousands of other users connected to hackers. All those users must be moved a step back, which is like very time consuming and scary. And that's why I've chosen linked list to implement it. So let's implement it. First, what are we doing? First, we are declaring a temporary variable using a malloc function, and it's of size user. So let's declare it. I've declared a temporary variable which points to a, which point here. Now get the name of the user from the parameters. So the user which we get, we are going to copy it to the temp arrow name, which we have already done here, so no need to worry about it. The next thing is, it's obvious that when a new user is created, the he doesn't have any post, he doesn't have any friends, so we are assigning everything, all of it to null. The next thing is if we are checking that if head is equal to null or what. So in this case, our head is not assigned to anything. It doesn't point to any node. So in that case, what we are doing is we are going to assign head equals to temp. Let's do it. We are going to assign head equals to temp. So that's all. Add user is that simple. Now we have created a user successfully. Now let's perform the same function for adding another user. Let's say we're going to add Spider-Man. Spider-Man is created. Now we do the same things over here. We are saying we copy the name Spider-Man from the parameter to the variable and assign it here. Then what are we going? Then we are going to assign all of the basic things such as next, friends, and post to null. Consider everything is being done already. Now comes the important part. Now we are checking if head is equal to null or not. You can see head is already pointed to a node, so head is not null. So next, what are we gonna do? So this case doesn't satisfy. So if this doesn't satisfy, we're going to go inside else. Inside else, we declare another pointer which points to head. Let's do it. Okay. I created a pointer and it's pointing to head. Now what's the next thing? We are going to traverse the linked list until the pointer arrow next is not equal to null. Let's do it. We are here. Let's see the pointer arrow next is null or not. Pointer is pointing to this node. This node's next is null because it's not pointing to anything, right? So we stop here. We stop there, and what do? We do pointer arrow next is equal to temp. Let's do it. Pointer arrow next is equal to temp. So we are going to point it. That's all. We have added another user to the list, to the linked list. That's the job of pointer and temp. Similarly, let's add Viva. Viva would be temp, and inside the while loop, we see that ed is not null, so we have pointer. Pointer arrow next is not null, so we move here. Pointer arrow next is null, so what do? We do the same thing. Pointer arrow next is equal to temp. That's all. These variables work has been done. So similarly, we can add hacker, and that's the way user is added to our database, our linked list. So we just saw about adding a user. So talking about the time complexity of adding a user, considering the way I implemented it, would be big of n, but it can definitely be optimized to make it bigger fun. So this can be done by adding users at the beginning of the linked list rather than adding it at the end of the linked list. So this is a simple change which I will be implementing in the future. So let's take the time complexity for adding a user in the linked list as big of 1. Now let's look at another feature which is adding a post. So it's obvious that every user has access to post their own pictures of images or videos, but in this case we are like, for simplicity, we are taking a character. Now we get two parameters, which is the name of the user and their post. The first thing that we do is we are going to have a pointer variable which points to head. Let's do it. We have a pointer variable that points to head. The next thing, what happens is we are going to check if the pointer arrow name is the same as the name which is given in the parameter. Let's do it. Okay, before that, which user, let's take the name given in the parameter is Spider-Man, because Spider-Man wants to post a picture. Now we are going to check if ptr arrow name is the name given in parameter. No, it's not. ptr arrow name is Vishal, but we want Spider-Man. So what we are going to do is we are going to move ptr to the next node. Let's do it. We moved it here. Now we check it again. We check if ptr arrow name is a name given in parameter. Yes, it is. They both match. So ptr doesn't move forward. It stays here. The next thing that we're going to do is we're going to create a temporary variable to store the post information. Let's do it. We have a temporary variable. Now we are going to store the post information over here. Let's say the post name is post1, which is given in the parameter. Yeah, temporary variable points here. Next is we are going to check if ptr arrow post is null or not. ptr arrow post is definitely null because Spider-Man has no post as of now. So it's definitely null. So ptr stays here. And what happens? ptr arrow post becomes temp. So we have a temp variable here. So ptr arrow post is assigned to temp, which is assigned here. So Spider-Man as a post now. See, a post has been added. Let's try to add another post. Points to temp as seen in the code. Let's name it post2. Now what you're doing is it checks if ptr arrow post is null or not. This comes from here, then comes here, then stays here. This checks if ptr arrow post is null or not. ptr arrow post is not null. because ptr arrow post is pointing to a node, so it's not null. So what happens next? So if this doesn't satisfy, we are going to have another pointer named ptr1 which points to ptr arrow posts. Let's take this, it points here. Let's make it a little small. Yeah, it points here for now. And we are going to traverse until ptr1 arrow next is not null. We can see here that ptr arrow next is null. So we are not going to traverse anymore. We are going to stay here, and ptr stays here. We're going to make ptr arrow next as temp. Let's do it. Temp is here. ptr arrow next is ptr is here. So ptr1 is here. So ptr1 arrow next would be post 2. In, similarly, we can keep on adding posts. So this function is also over. Now talking about time complexity. First, we are given name and the post. So first, in order to find the user, we need to traverse the user linked list, which takes a time complexity of big O of n. Then let's say the user who wants to post the file as m posts already. So in that case, to add it, we have to traverse m times. So it would be big of n plus n. But this can also be optimized. A post can be added at beginning. A post can be added at the beginning instead of adding at the end as I did here. So in that case, the time complexity would be big of 1 year and big of n year, which tends to be big of 1. So time complexity would be big of 1 year. It's ideal case, but I've implemented as big of n plus n, which I'll be changing. So now we finished add post. Now we'll be looking into show post. Show post is done in a similar manner. Let's remove everything. Okay. Now we get the username from the parameter and we assign a pointer to it. Let's do it. The same thing. The next is we're checking if ptr arrow name is the name which is given in the parameter. No. In this case, we want to check for Spider-Man, but the name over here is Vishal, so we're going to move forward. Yes, the name given there and here matches, so pointer is going to stay here. The next thing what you're going to do is we are going to create another pointer called ptr1, which points to ptr arrow post, so it points here. Now we are going to traverse this whole linked list until ptr becomes null. So here ptr is not null, so this post 1 is printed. Next ptr goes here, it's not null, so post 2 is printed. ptr goes here, null, and the loop breaks. So in this case we can see all the post has been printed. Similarly, we can like map all those images in an Instagram file. That's how like I think it's implemented. So for this, definitely the time complexity would be big of n plus m because it can't be further optimized. We have to search the user, which would take big of n time complexity, and we have to traverse through all the posts, which would take big of m time complexity, considering that there are m posts. So we just saw how to add a post and to show all the posts of a user. Now we're going to look into how to add friends, how to make connections between two users. So for our example, let's take, we have to make Vaibhav and Hacker both friends. So we have to make a connection between them. Let's see how to do that. First, to do that, we have to create two pointers, pointer 1 and pointer 2, both of which are pointing to head. Let's do that. Pointer 1, pointer 2. They both are pointing to head. Now let's see what the next step is. The next step is the same thing which we did when we are adding a post. What we're going to do is we are going to traverse the whole linked list until we find the user which is mentioned in the parameter. So the mentioned names are Vaibhav and Hacker. So we are going to traverse the whole linked list until we find them. First we are going to do for ptr1, which checks for name 1, which is Vaibhav. Let's do it. ptr1 checks for Vaibhav, but it's Vishal over here. We traverse. This is also not Vaibhav. We traverse. Yeah, finally we reach Vaibhav. So pointer one is happy and it stays here. The loop is exited. Next, we're going to do the same for pointer 2, which checks for the name 2. In our case, it's Hacker. Let's do it. No, it's not, it's not. And finally, we reach hacker. Pointed to is also happy. Now, let's check the next step. The next step is creating two temporary variables, temp1 and temp2, which is of size struct user. And in temp, and if you know struct user's data type, it has a name inside it. So we're going to copy the name one given in the parameter to temp1's name and temp2's name. Let's do it. So in temp1 name, our parameter given name is Vaibhav. Let's make it yeah. And temp2, it's hacker. Oh yeah, we have assigned it. Now the next step is we done it. Obviously, let's assign all the other values to null. That is the next pointer because we don't have any next friends over there. So the same goes with friends and posts. Now we are going to check the friends list now. So let's say PTR1. PTR1 is here, PTR2 is here. We are going to check if PTR1 arrow friends is null or it has or if the user already has any friends. So in our case, PTR1, that is Vibo, has no friends. So we are going to go inside this loop and the PTR1 arrow friend is being assigned to temp2, which is this. Let's assign it. This is done. Now we're checking the same thing for PTR2. We're checking if the friends list is empty or they already have friends. Hacker doesn't have any friends. So it goes inside PTR2 arrow friends is equal to temp1. Temp1 is Vaibhav. So we're going to do the same thing. Now you can see they both are friends. Vibo is a friend of Hacker, Hacker is a friend of Vibo. Now it's consistent. Now we are going to do the same thing again. Let's do it for Vibo. Me and my brother Vibo, we already are friends, but let's take for examples. Let's take for an example that I want to become a friend of Vibo. So this resets. PTR1 goes to head, PTR2 goes to head. So PTR1 traverses till it finds Vishal. It already found Vishal, so PTR1 stays here. PTR2 traverses till the name 2, which is Vaibhav in our case, so it goes to Vaibhav. PTR2 is happy, PTR1 is also happy. Now what you're going to do is assign temporary variables. You can see here, temporary variable name is name1 and temporary variable name 2 is name2. Let's do it. Name1 goes here, name2 goes here. Now we are going to check if PTR1 arrow friends is null or not. The same thing, PTR1's friend is empty. So what we're going to do is we are going to create a friends list and assign it to name2, which is Vivo in our case. The temp2 is being assigned to PTR1. And in PTR2, we are going to check the same thing. If you remember, we did it previously. But in this case, we do not have PTR2 arrow friends as null. We already have a friend because Vibo is already a friend with Hacker. In this case, what we're going to do is we enter into this loop. In this loop, we have another pointer which points to PTR arrow friends. For now, let's take temp2 as this pointer. It points to PTR2 arrow friends, which is Hacker. Now we traverse inside the friends list. So PTR, in our case temp2, it traverses until it finds temp2 arrow next is not equal to null. But temp2 arrow next over here is null, so temp2 stays here. Then ptr arrow next is equal to temp1. In our case, temp arrow next is equal to, we do this and we assign it. So we can see it's consistent. Vaibhav is a friend of Vishal and Vishal is a friend of Vaibhav. So everything is consistent. This is how it goes. So talking about the time complexity, let's say to find the user, it takes big O of 2 times of n because you're finding 2 pointers, but in time complexity constants are avoided, so it takes a big O of n. And for traversing through the friends list, it takes big of n, big of m, let's say. So the overall time complexity is big of n plus big of m, which corresponds to big of n plus m. So we are done with adding friends. Now let's see showing friends. Suppose I want to know who are all the friends of Vaibhav. In that case, what are we gonna do? Let's see that. So what we're going to do, we're going to assign a pointer to head. Let's, for simplicity, take this as pointer, even even in the case it has one. Then what you're going to do is same thing. We're going to traverse until the pointer name corresponds is equal to the name provided in the parameter. The name provided in the parameter is Vaibhav, but PTR1's name is Vishal. We go here, it comes to Vaibhav. Then we are assigning another pointer. Let's take that pointer 2. It points to PTR arrow friends. So pointer 2 points to PTR arrow friends, which is this thing, and we're checking if it's null or not. It's not null. So what we're going to do, we're going to print hacker. Hacker is being printed as Viber's friend, and it's not null, so PTR traverses, and Vishal is being printed as Viber's friend. Then PTR traverses, it's null, so the loop is exited, and that's all. And that's how we can get every user's friends detail. The time complexity for this is for finding the user, it takes big of n time complexity, and for finding the and for traversing through all the friends in the friends list, it takes big of m. So overall, it takes big of n plus m. Now let's consider this case. There has been a fight between Vaibhav and Spider-Man. I don't know what happened between them, but they're not friends anymore. In that case, what happens? They both unfollow each other on social media, right? So that's what we're going to look into now. So we're going to look into how to remove friends from the database or from the linked list for now. So what's the first step? First step here is we are going to assign two pointers to Ed. Let's do that. Yeah, it's already assigned. Let me make it a little smaller. Okay. Next, we're doing the same thing. We are traversing the user array until we find the name which is given in the parameter. In our case, it's Vaibhav, which is name 1, and Spider-Man, which is name 2. Now, well, let's look for pointer 1. Pointer 1 checks for Spider-Man. Let's do that. Pointer 1 checks if this is Spider-Man. No, it is not. So pointer 1 moves to the next node. It checks if pointer 1 arrow name is Spider-Man. Yes, it is. So this one is satisfied. Now let's go to the second while loop, which is for pointer 2. In our case, pointer 2, which is given in parameter, is Vaibhav. So pointer 2 checks for Vaibhav. No, pointer 2 is not satisfied over here. So pointer 2 moves here. It's not satisfied as well. So pointer 2 moves here, and now it's happy. So pointer 2 stays here. Next, the while loop's over. The next thing that we're going to do is we're going to assign a pointer to pointer 1 arrow friends. Let's do that. We have a pointer which points to pointer 1's friends. So for now it's Viber. The next step is we are checking if pointer arrow name is the same as name 2, which is Spider-Man. Sorry, which is Vaibhav. So yeah, it's same. So let's see what happens then. Then what happens? Pointer 1 arrow friends is equal to pointer arrow next. Pointer arrow next is null, right? So pointer 1 arrow next points to null. So there's no connection over here. This is removed. Then what happens? Then pointer is freed. Pointer is freed. Let's free the pointer. Spider-Man. By Spider-Man, from Spider-Man, Vivo is removed. Now we have to remove Spider-Man from Vivo. Let's see how that happens. The next thing is we are moving here. Here, pointer is equal to pointer 2 arrow friends. Let's do that. Let's make a different pointer. Okay. Pointer points to pointer 2 arrow friends. It's pointed. Now what are we doing? Here it's checking if pointer one arrow name is equal to Viber or not. Let's check. No, pointer one arrow name pointer arrow name is hacker. So this is not satisfied. So we'll jump into else loop. Here it checks if pointer arrow next arrow name is equal to the given name or not. Let's check that. Pointer arrow next arrow name is equal to given name or not. Pointer arrow next arrow name is Vishal. So it's not satisfied. Then what happens? Pointer moves to the next node. Let's move it. Now it checks. Now it checks again. It sees if pointer arrow next arrow name is given. Next arrow name is equal to the given, which is named one Spider-Man or not. Yes, it is Spider-Man. So let's see what happens. Yes, it is Spider-Man. So what happens is a temp variable is created to pointer arrow next. Let's create a temp variable. Okay, it points to Spider-Man. Now see PTR arrow next PTR points to temp arrow next over here. PTR arrow next, which is this arrow mark. It points to temp temp arrow next, which is null. So no need to give this pointer. Next, what happens? We are going to free the temp variable. Let's free it. See, now Spider-Man is removed from Vibo's friend and Vibo is removed from Spider-Man's friend. This is how this is how friends are removed from the database, or let's say from the linked list. So for the time complexity, what happens is it takes big O of 2n, which we can say is big O of which we can say as big O of n, and for traversing through the users friends it takes big O of m. So the same thing, big O of n plus big O of m. Now let's talk about the next and the final function, the feature which is mutual friends. So what are mutual friends? Mutual friends are nothing but the common friend between user A and user B. So let's see an example. Um, so the mutual friend of Spider-Man and Hacker is Vibo because Vibo is a common friend of both of them. Now let's see how to identify mutual friends between two given users. Let's do it. So what's the first thing that we gotta do? We gotta do the same thing. We gotta assign two pointers to the head. Let's do it. Pointer one and pointer two. The next step is we are going to check if pointer one arrow name is equal to the given name. That is name one. Name one. Let's take. Okay. Let's check the mutual friends between Vishal and Vaibhav. So name one would be Vishal and name two would be Vaibhav. Let's do it. So pointer one is Vishal, so it stays here. Now this is over. Now let's go to pointer two. Pointer two checks if the given pointer's name is equal to the given name too, so it should check if it equals to Vaibhav. No, pointer two's name is not Vaibhav, so it goes here. No, it's not Vaibhav, then it moves again. Now pointer two's name is Vaibhav. So it satisfied these two. So while loop is exited. Now what's happening is we are assigning a pointer to pointer one's friends. Let's do it. We are assigning a pointer to pointer one's friend. We have assigned it. Then what are we doing? Then inside a while loop we're checking if pointer is null or not. We're going to traverse the whole friends list until it becomes null. Then the next thing is we are assigning a pointer 3, another pointer to pointer two's friends. Let's do it. Pointer 3 is assigned to pointer two's friends, which is over here. Let's make it a little small. Okay, perfect. Now where are we? Over here. Now we are checking if point we are going to traverse through that list. Point friends the second friends list until it becomes null. And we are comparing if pointer's name is equal to pointer three's name. And if they are equal, we are going to print it. Let's do it. So what are we going to do? We are going to traverse through pointer two friends list until it becomes null. So what are we doing here? We're checking. We're checking if this name is equal to this name. No, they are not equal, so pointer 3 moves here. We're checking if they both are equal. No, they aren't equal, so it moves here. Checking. No, they aren't equal, so it becomes null, and the while loop breaks, and the function is exited. So in this case, we can identify that there is no mutual friends between Vishal and Vaibhav. Now let's take an example where we can find mutual friends. So I'll add it. Let's make Vishal and Spider-Man friends. Okay, let's remove everything. Okay, perfect. Now let's do it again. We're gonna do the same thing. Okay, let's do it. Pointer 1 and pointer 2 pointing to head. Again, we are going to find the mutual friends between Vishal and Vaibhav. So pointer 1 checks for Vishal, it already is in Vishal, so it stays there. Pointer 2 checks for Vaibhav. Nope. Nope. Yes. So pointer 2 stays here. The next step is assigning pointer to pointer 1. Let's do it. Pointer to pointer 1's friend. Here it is. We did it. Then what are we doing? We're going inside the while loop and creating a pointer 3 which points to pointer two's friend. Let's do that. Pointer 3 is over here. Let's point it to pointer two's friend which starts from here, that is hacker. We did it. Then what are we checking? We're checking if pointer name, the name, this name is equal to pointer three's name. No, it's not equal. Then what are we doing? We're traversing it. Are these equal? No, they aren't equal. So we're traversing it. Again, they aren't equal. So it becomes null. And the inner while loop is exited. We still have the outer while loop. Don't forget that. So what are we gonna do again? So what I outer while loop does is it changes the pointer to pointer our next first, and the next loop continues. Let's do that. Pointer comes here, and this loop also inner loop resets, so it comes to pointer two's friends. So now we're gonna do the same comparison again. So it checks if these two names are equal. No, they aren't equal. So pointer three moves here. No, they aren't equal. So pointer three moves here. At last, we got a same. We got a mutual friends. That's what mutual friends are. They both are common friends of Vishal and Vaibhav. So we're gonna print Spider-Man and mutual friends. After printing after this, again the loop continues. Pointer one goes here. The outer loop exits. This also exits. We got the mutual friend of Vishal and Vaibhav, who is Spider-Man. That's the implementation of show mutuals. I guess that's the end of it. I've covered all the functionalities. Let's check it once again. Yeah. Add users, add friends. Yeah, almost all the explanation is completed. Maybe the implementation or of the algorithms may not be in the most optimized manner, or it may not be implemented the way they are being done in the industry. But that's not the whole concept here, right? The whole concept over here is like learning data structures and algorithms, not by just grinding lead code or doing comparative programming, but using the data structures that you learn to solve real world use cases. So this social media thing is a real world use case. Maybe it's not implemented in this manner, but you have used knowledge of data structure and algorithms to solve it in your own manner. That's what the learning is all about. And I've also attached the GitHub link of this whole code in the description down below. So please feel free to clone it and start playing with it. If you can make it more optimized, better for you. And like start playing with it, break the code, see what happens, fix it again. That's where the learning comes. That's it from my side, guys. I'll meet you guys in the next video.